let's look at an example. If x plus y equals 8 and x minus y equals 10, we can use a property of addition for solving equations, which tells us that if we add the same thing to both sides or subtract the same thing from both sides, the resulting equation will still be true. Well, if we know that x minus y equals 10, and we add x minus y to this side, and we add 10 to this side of the first equation, what we'll end up with is another true statement. And that true statement will be 2x equals 18. What's the big advantage? There's no y's here. So we know that x divided by 2 must be 9. And if x is 9, then we must have that 9 minus y equals 10, substituting in here, and that will give us that negative y equals 1, or y equals negative 1. That tells us that the two lines that we would get from graphing these two equations do indeed intersect, and they intersect at the point 9, negative 1. And if we went back and checked those, we'd find out that 9 minus 1 is 8, and 9 minus negative 1 is 10, and so they would indeed also check. This system is consistent, and here is the single answer. Now let's look again. You say, well, that's really nice because they just were opposites and they canceled out. What if they're not? Well, let's see what if they're not. If 2x plus 3y equals 11 and x minus y equals negative 7, you'd say, well, if I add these together, I get 3x plus 2y. Well, the y's, neither one disappeared. If I subtracted, then I wouldn't be in any better shape. They'd still have two variables in them. So what indeed should I do about that? Well, what I can do about that is to look and see what the coefficients are in front and realize that if I multiply everything here by 3, the system would now look like this. 2x plus 3y equals 11. But now my second equation turns into 3x minus 3y equals negative 21. Now I've got just what I was looking for, because now I've got coefficients that are opposites. And when I add, I'll get 5x equals negative 10. And that'll give me x equals negative 2. And if I go back up here and say negative 2 minus y equals negative 7, going back to my original here, negative 2 minus y equals negative 7, I'll get negative y equals negative 5, so y equals 5. The ordered pair, that is the intersection of the graphs of these two equations, is in fact negative 2, 5. And if we needed to check those, which we should, we'd go back up to the top and we'd find out that, let's see, negative 2 minus 5 is negative 7, so it checks in the first equation. If we put negative 2 in here and 5 in here, we'll find out that we get negative 4 plus 15. Negative 4 plus 15 is 11, so it checks in both equations, and we have solution.